Mankind began their quest of the unknown by looking up at the sky. In the 17th century, Galileo looked through a telescope and triggered a scientific revolution. 2009 is named the International Year of Astronomy to commemorate humans' first up-close look at the universe 400 years ago.
Starry, starry night, flaming flowers that brightly blaze, swirling.
In Vincent van Gogh's painting Starry Night, the night sky is filled with dynamic swirling stars reminiscent of spiral galaxies in the universe.
People, even a few thousand years ago, were interested in what is the sun, what is the moon, or why do they move?
Van Gogh turned imagination into art. He applies imagination to science.
So these are very old questions, continue to remain interesting to us as human beings.
Behind the swirling spiral arms, what secrets await to be unveiled?
1,000 years from now, people will still be studying the sun and the moon and the stars and the universe. It's because new questions always arise.
In the desert of California, 2,400 meters above sea level, the sky is clear and the air dry. This is KAMA, the world's most powerful millimeter-wave radio astronomy observatory. With an array of 23 antennas, it tracks, round the clock, minuscule changes in the vast universe, allowing astronomers to probe its mysteries.
Through telescopes, we can see that our Milky Way is not the only galaxy in the universe. It's only one of the maybe 10 billion that we can see with telescopes in principle. And even beyond what telescopes can now examine, there may be many more galaxies. So right away, one gets this feeling of being very small in a very large universe.
Dr. Frank Shu is this year's Shaw Laureate in astronomy. He was born in Kunming, China in 1949. At the age of 6, he emigrated to the United States, where his career in astronomy began. Now a professor of the 10-campus University of California system, he focuses on theoretical astronomy. Many of his theories have been validated with data collected from high-precision telescopes. The son of renowned mathematician Su Xianxiu, Frank wasn't really interested in astronomy as a young boy. He fell in love with mathematics in his father's footsteps and physics, his major at the Massachusetts Institute of Technology. It was Frank's senior year mentor, Professor C.C. Lin, who sparked his passion for astronomy.
It was through him that I really discovered what doing research meant. It was completely different.
Frank went to Harvard University to major in astronomy, a field of study he feels integrates various scientific disciplines.
Astronomy has both physics and mathematics in it, but it has, in addition, connection with human interest, human history, and human philosophy that makes it even more interesting.
In 1964, Frank and mentor C.C. Lin jointly published a paper on the spiral arm structure and density waves in galaxies that remains a key fundamental theory of astrophysics for 4 decades and propelled Frank to the forefront of astronomy. The Earth orbits the Sun, but our Sun is only one of 100 billion suns in our galaxy. And the Milky Way is just one of about 30 billion galaxies in the universe that have so far been observed. Many galaxies, like the one Earth is in, are in spiral shapes like windmills.
Because the property of gravity is that it likes to pull things into the center. If you have a spiral shape, then over time, every time you go through, even though it tries to go back out, it goes back less far than it should. So it ends up being a little closer to the center.
The stars in the spiral arms also orbit the center of their own galaxies, but in parts of the galaxy that appear as spiral arms, their paths are more concentrated, like a traffic jam.
Let's say 4 lanes. If there's some work going on that closes one of the lanes, then 4 lanes become 3 lanes. All the cars go slower, plus they have to get closer to each other, so the density goes up. That is a traffic jam. Similarly, in a galaxy, the stars and the gas clouds are going around, and as they go through the spiral arm, they cause a little jam. But as they leave the spiral arms, they again separate. And that's why when you take a picture of a galaxy, it's much brighter in the arms.
Frank Hsu and C.C. Lin's density wave theory does not only explain the formation of spiral arms, but also the movement of stars towards black holes in the galaxy's center.
Every time they go through a traffic jam, will get pulled a little closer to the center of the galaxy. That's as if when you get pulled to the center of the city, 3 lanes only become 2 lanes. The traffic jam becomes worse. 2 lanes becomes 1 lane. The traffic jam becomes even worse. When 1 lane disappears, you have complete jam. No car leaves. You accumulate a very large mass in a very small volume of space. Then it becomes so dense that light cannot escape from it, and it becomes a black hole.
This density wave theory also helps us understand the structure of Saturn's rings. Saturn's rings comprise thousands of layers of ice and dust, with many gaps between the layers. Frank's theory shows that the gaps are caused by the gravitational pull of Saturn's moons, causing traffic jams of ice and dust particles in the rings, and the density waves generated by the rings' self-gravity. Frank was 21 when he published the theory, which he credits to his mentor and to luck. A friend once joked about his early success.
His comment was that I had reached the peak of my career with the very first paper I wrote. When I started this work with Professor Lin, I was only 19 years old. So, it's rare that a 19-year-old would become known throughout the scientific world of astronomy. But to be honest, the main credit for this work should go to Professor C.C. Lin. It was his insight that suggested that spiral structure would be associated with the density wave. I merely helped him with some of the calculations.
Frank is now based in San Diego, California. It's on the Pacific coast near the American-Mexican border. While being an important military port, it's also developing in recent years into a center of technological innovations, including biotechnology. Frank is a professor of the University of California, San Diego, which became a world leader in technological research in its short 50-year history. This flag in the university's Center for Astrophysics and Space Sciences symbolizes its contributions to U.S. space programs.
This is a flag that was flown in 1981 in the Columbia Space Shuttle, and was given by the 2 astronauts, John Young and Robert Crippen, to University of California, San Diego.
Dr. Mark Thiemens, who had invited Frank to teach at UC San Diego, says Frank is a distinguished scientist as well as an outstanding educator. The Physical Universe, a book Frank wrote in 1982, has become a popular textbook for undergraduate astronomy and a standard reference in Harvard Graduate School.
From detailed
I was one of the students that used it. It's well written, it's clear, it's easy to understand, and it's a difficult topic. Frank's really great at helping people understand things.
In the past 2 decades, the book has been translated into many different languages, drawing people around the world to astronomy to unlock the secrets of the universe.
It had a lot of influence. I'm probably better known for this book than for all my papers. The book was at 2 levels. Was a descriptive part, which is like a story, and a quantitative part, which I left to problems that the student who was interested could work out on their own. At the end of each chapter, I would have a philosophical section or historical section that would put what we just learned in the context of human experience. In the United States, frequently you were the only person in your class who was Asian. One wanted to be more like American. We were half ashamed to be Chinese. Didn't like our own culture, our own philosophy. These curved roofs with the curved tiles coming down and the mythical figures, very Chinese. And so I never felt an affinity to it. And as I traveled more in the Far East, I began to appreciate this is a whole branch to human civilization, human accomplishment that I have connections to.
Shaw Astronomy laureate Frank Hsu emigrated to the United States at 6 years of age. Immersed in Western ways and thinking, Frank never imagined working in a Chinese society. Until 2002, when Taiwan's National Tsinghua University invited him to be its president. Coincidentally, both he and his father, Xu Qianxiu, became head of Tsinghua at the age of 58.
Tsinghua for me was always a kind of a magical name. I really felt that I owed it to my father's memory. I owed it to the Tsinghua legacy. I owed it to my friend Y.T. Lee to come.
Nobel Prize winner Yuan Li had invited Frank to head Tsinghua. Li says no one expected the president of the American Astronomical Society to give up everything to come to Taiwan. Subsequently, Frank helped elevate Taiwan's status in global astrophysics.
His major contribution was to organize Asian American astronomers to establish the Institute of Astronomy and Astrophysics here in Academia Sinica.
Li says Frank initially turned down the presidency for fear his family wouldn't adapt to Taiwan's lifestyle. To entice him, Li found a villa for Frank near the university. But after he agreed to come to Tsinghua, Frank insisted on living in a flat on campus.
We lived in the top floor. For me, no matter what I'm doing, so all-consuming that I sort of lose track of my surroundings anyway, so it wasn't such a sacrifice for me. It was convenient.
At Tsinghua, Frank spearheaded innovation, establishing TIARA, a theoretical institute for advanced research in astrophysics, and encouraged students to learn foreign languages. He set a target of 2020 to make Tsinghua one of the world's top 20 universities in 20 years' time.
I wanted to set the bar high, so high that it would take the best effort of everyone to try to reach it. And even if you exert the best effort, maybe you will only get 80% of what you hope for. But that would mean we have one university in the top 25. That's not so bad.
To achieve his aim, Frank recruited renowned overseas academics to teach at Tsinghua. Rainian Kuo and husband Ming Wei Hong had worked for decades at the prestigious Bell Laboratories in the US. They brought with them their entire lab at Bell, equipment worth $7 million.
those very complicated equipment and very advanced equipment, through the Panama Canal and to the
Pacific Ocean and Taiwan.
Taiwan, not a single part
Was damaged.
It's
like a miracle. It's time to return to our home country, Taiwan, to help the young generations to build up the passion for physics and do the first-rate research, and to help them to grow, so that the whole country will move forward in that regard.
This is unnecessary, to have so much light, to have air conditioners go on full blast, just to entice people into the source. That's a terrible waste of resources.
Taiwan's night lights obliterate the stars in the sky.
Many urban children grow up without ever really seeing the night sky in its full splendor. And when you can see such vistas, your attitude toward the natural world changes, because you realize how vast this whole universe is.
Frank not only brought overseas experts to Taiwan, he also sent Taiwanese astronomers to observatories elsewhere. The peak of Mauna Kea in Hawaii is the best site for sky watching in the Northern Hemisphere. Some of its 8 telescopes are among the world's first sub-millimeter array, with resolution so powerful that if they were atop the 508-meter-tall Taipei 101 building, they could spot a ladybug in the Taoyuan International Airport more than 40 kilometers away. 2 of the telescopes were built by Taiwan's Academia Sinica, an achievement spearheaded by Frank Hsu. Earlier, Frank was instrumental in getting Taiwan to join with the Smithsonian Astrophysical Observatory to build their own sub-millimeter telescope.
We wanted to build our own telescope to learn the technology, to train the people, so that the next project, Taiwan could lead and, in fact, be self-sufficient. And we have arrived at that stage today.
After the completion of the telescopes in Hawaii, the Academia Sinica was allotted 15% of observation time, giving Taiwanese astronomers more star-gazing opportunities. Another of Frank Hsu's contributions to astronomy is his theory on star formation. Through the telescope, we can see magnificent clouds. They are the cradles of stars. We used to think stars are born through the gravitational collapse of gas clouds before rings of material are shed to form a disk surrounding the nebula. But Frank and other astronomers found it's in fact the other way around. First, a disk is formed by rotating, contracting gas clouds. Dust particles on the periphery are held in orbit by gravity and condensed into planets, while the material in the center becomes a star.
All these stars, when they're young, have very strong magnetic fields. It's just like a stone in a sling. It would be flung from the sling and carry away all the angular momentum. So what is left is something that's rotating very slowly. And because it's rotating slowly, it would become a ball.
The strong magnetic fields of the star will whip up the surrounding gas. The gas that remains will evaporate in millions of years to form a planetary system. Gravity, magnetic fields, and turbulence all play a role in this.
I've used my knowledge of pool and billiards in astrophysics, at least as models to guide the thinking.
So Mike, who plays better, you or Professor Hsu?
I think I'm better by that much.
Frank loves billiards. He says you can improve yourself through competition.
Competition is a crucial part of doing scientific research, because it's through that competition that the truth, or better approximations to the truth, emerge.
After heading Tsinghua for 4 years, Frank and his family settled in San Diego. He met his wife Helen during their university years in Boston. Helen majored in biology. They've been married for 40 years. Frank was so intent in his research that it sometimes caused trouble.
So I remember before we got married, I had an observational project which required me to be at the observatory for about 2 weeks. And telephone was not very handy to get to. So during that time I was working at night and sleeping during the day. So I didn't manage to get through to talk to Helen for 2 weeks. She was very mad by the time I did call her. She wouldn't speak to me, so I had to try to speak to her through her friend. I was afraid she wouldn't forgive me, but eventually she forgave me.
He forgets the cause because he's so focused. He has great powers of concentration on his work. That's also what makes him so productive, is that he spends long periods very focused and very intense on his work.
At leisure, Frank and Helen love gardening. He's also writing more astronomy books to promote the subject. He says he's grateful for his wife's support over 4 decades.
I feel we have a good partnership. And I know in some areas it's unequal. I'm not home lots of the time. She undertakes work that more than her share. Without Helen, certainly my life would be very different and probably much shorter. But I can't imagine life without her now.
Watching the universe, Frank is aghast that continuous carbon emissions will destroy the ozone layer. In California, he has seen how arable land turns into desert.
We have the power to change the earth. You look around, you have no idea. At one time, this was a very green area. When Los Angeles was growing very fast, it took the water from Owens Valley, which then was a green, fertile farmland, orchards everywhere. Gradually over time, Owens Valley became a desert. This is what will happen to many parts of the world if we have climate change, global warming.
In recent years, he's shifted his focus to global warming and energy resources. He says using nuclear power is one way to reduce carbon emission.
Solar energy is very expensive. Also, when it's cloudy, well, when you have fog, you don't have solar energy. We have to have a backup, and that backup is nuclear power. But right now, all the discussions of alternative energy, the first thing that happens typically is to eliminate nuclear power from the discussion. All right? Once you eliminate nuclear power, there is no solution.
Amid global warming and energy crises, Frank says the new generation should not pollute the environment.
Now, for my generation, grew up with a throwaway culture. But you use it once, you throw it away. In America, it's much cheaper to buy a new appliance than to fix an old appliance. This cannot continue. But every generation owes a responsibility to the next generation. The whole universe began 14 billion years ago. So that's the span of the history of the universe. If the whole universe was shrunk down to 1 year, it would just be that. Although we are tiny little specks in the universe, in fact, in terms of quality, the human brain is the most complex thing we have ever encountered in science. Nothing astronomers see in this vast universe approaches in complexity and elegance the human brain. People should develop their talents to the fullest because they have a very brief span available to them.